Welcome, ladies and gentlemen, to your video on triangles and quadrilaterals for your geometry unit here. You're going to hear Charlie in the background probably, so enjoy that. It's going to be two different learning targets. So the first one is triangles from 10.4 of the text that we are using currently, and it's I can identify and classify triangles. So some vocabulary that you need to know is up top here. What a triangle is, congruent and congruent segments, acute triangle, obtuse, right triangle, scalene, isosceles, and equilateral. So there's going to be a lot of vocabulary, possibly a lot of drawing. So make sure that you're taking your time and making sure you know the difference. And that your notes are nice and neat and labeled with those different things so that you can use them. So here we see a triangle. We should know that a triangle is a three-sided figure with three different angles. The symbol triangle is used in math to read triangle, and then usually it'll follow with letters like triangle ABC or triangle DEF to note that. A very key and important concept we need to know about triangles is here, key concept, is that a triangle has 180 degrees. The sum, meaning if you add all of these angles together, they are going to equal 180 degrees. So in algebra, we can use the equation that we always know the three different angles will add up and have a sum of 180. So good key information to have there. Obviously, you don't have to write this whole sentence, but having this information would probably be really good. So knowing that you know a triangle has 180 degrees, you can use algebra. Algebra meaning using letters in place of numbers we don't know, bless you, Charlie, to find the missing angle that we don't know, knowing 180. So here in this triangle, we have angle XYZ, and what we do know is that triangle X, sorry, I'm using a new style, it's kind of tricky, XYZ, the sum of all those angles is going to equal 180. So we know that the measure of angle X plus the measure of angle Y plus the measure of angle Z are all going to equal 180. So we can replace the values we do know. We know X measures 43 degrees plus Y equals 119. Plus we don't know the measure of angle Z, but we do know all together that it'll equal 180. So then we can add our 43 and 119 together for a total of 162 is the angles we do know, plus the missing angle is going to equal 180. So we go back to our unit where we learned one-step equations. So saying something plus 162 will get me to 180, meaning you can do your train tracks. Without that 162, then that would leave us with just the measure of angle Z that we didn't know, which would be 18 degrees. And based on that picture, that's a reasonable answer because it's a pretty small angle. So if you feel comfortable, go ahead and try this next one. There's not a picture, but it's written out in words. It's always good to try on your own. So it says triangle ABC has measures of angle A is 25 degrees, angle B is 108. So what is the measure of angle C? Again, using what I do know to find what I don't know, I know that the measure of angle A plus the measure of angle B plus the measure of angle C is going to all be equal to 180 degrees. So I replace what I do know. A is 25 plus B is 108 plus the measure I don't know, and you could just do C here. I like to do measure of angle C so I know what it represents. And then I'm going to continue to solve. So I'm going to add those together, and I get 133 plus what measure is going to equal 180. So I'm going to take that 133 away to find out what's left over, and I realize that the measure of angle C is equal to 47 degrees. So now that you've seen two examples, this might be a good one where you want to try. You're just going to find the missing angle of the frame of the bicycle here. And it's multiple choice, so you could even rule out some answers if you feel comfortable with that too, kind of that test-taking strategy, but they're all pretty close. So again, we have a triangle here. You're given 89 as a measure, 60 as a measure, and then x is a missing measure, but we know since it's a triangle, they'll all add up to 180, so that's the common theme. And so then when you add those together, you get 149 plus what missing angle will give us 180. You do the inverse operation of adding, so you subtract 149 from both sides, keep it even, keep it equal. 149 minus 149 is 0, so we're left with one single x. That measure of x is equal to 31 degrees, which is answer F. So then the last part of this is determining, just classifying angles by some qualifications that they have, some similar rules that they follow. So every triangle has at least two acute angles. We can classify angles by their third angle, really, and then we can classify them by their sides as well. And based on their sides, we talk about congruent segments. Congruent, this is the symbol, and it really means equal in length. Okay, so notice here, we're going to kind of classify these. This you would want to put in your notes, the different types of triangles. So you want to pause here. So when classifying by their angles, you can call a triangle an acute angle. Remember I had that shirt, acute baby. Means that all of the angles are less than 90 degrees. Okay. A right triangle means that it has exactly one right angle. A triangle can't have two right angles because then these ones wouldn't meet. An obtuse triangle is when there's one obtuse angle. Obtuse meaning more than 90 degrees. Classifying triangles by their sides. A scalene has no congruent sides, meaning none of these sides have the same length measurement, denoted by those marks. Isosceles triangle is when two of the sides are congruent, and that's noted by those marks there. And equilateral, word equal, means that all three sides are congruent. Notice they have the same marking. They're all the same length. So your job is just to identify what type of triangles these would be by their sides and their angles. So I see that these are marked the same, so I know that that is isosceles. And by its angle measures, this isn't noted. It looks a little bit bigger than 90 degrees. So that would be an obtuse angle. So this is an obtuse isosceles triangle, or isosceles obtuse. The next one, I again see two congruent sides, so I know that's isosceles. And I also see a right angle noted there by this mark. When you see that, that means right angle. So it's a right isosceles triangle. And then finally here, I have three sides. None of them are marked the same, meaning that it is scalene, because none of them are the same length. And then again, I see that right angle mark. So this is a right scalene, or scalene right triangle. Easy as that. That chart's going to be super helpful. Put it in your notes, put it on a study guide. Next learning target, this goes with 10-6. It's classifying and identifying quadrilaterals. Now, so very similar to triangles, we're going to find missing measures and we're going to name them. So you're going to have to pause on the next slide and take some notes and then find some measures. So here's some vocabulary: quadrilateral, parallelogram, trapezoid, rhombus. These shapes should be familiar to you, so this shouldn't be too difficult. We will have a chart. You can just follow here. You can fill this in. We will have a notes foldable that you'll get to have this here too. Quadrilateral, the word quad means four, so it's a closed figure with four sides and four angles. So again, quadrilateral means, quad means four. That's why it's named by the four sides, four angles. Diagram shows how they can be related. It goes from the most general to the most specific. So quadrilateral, notice four-sided, four shape. No rhyme or reason to the angles or side measurements. And then a trapezoid is a type of quadrilateral, vocabulary word. It has exactly one pair of parallel sides, knowing that parallel means that they run and they're never going to intersect, and that's what those arrows denote. And A very common one is a parallelogram, and that has both pairs of opposite sides. So this side and this side are opposite of one another, and they are parallel, as well as this side and this side. So the opposite sides are both congruent and parallel. Within the realm of parallelograms, we have a rectangle. A rectangle is a parallelogram because both sides are parallel and congruent. The difference is that it also has 4 right angles, which then leads us to a square. A square is a parallelogram because it has 2 pairs of opposite and congruent sides, 4 right angles, but then all of the sides are also congruent. They're also the same length. A rhombus as well. This is similar to a square, but doesn't have the right angles, but it has 2 pairs of parallel sides, then all of them are congruent. So this takes some practice getting used to what falls in which category. So sometimes you have to name the best quadrilateral that best describes it. So you'd want to make sure you keep in mind the properties that define these. Okay? We're almost there. You guys are doing great. So realizing that a triangle we know has 180 degrees, if you split a quadrilateral that has 4 sides in half, you're left with 2 triangles. So if we know that triangle B is 180 degrees and triangle A is 180 degrees, that's 2 triangles at 180, so a quadrilateral is equal to 360. So you want to pause and write down this key concept, denoting that, again, we have an algebra equation that can help us find the angle measures, the sum of them, for any quadrilateral, any 4-sided. So this is our last one, these last 2 to try, and then you are free. So bear with me and try your best. So we're going to find the value of x. So again, we know that the angles that we are given, so that angle of 73 plus the angle measure of 59 and the angle measure of 85 degrees, plus that missing angle of x, since it's a quadrilateral, are all going to add up to 360 degrees. So when we add those all together, we are going to get, we add all these together, and you could do them one by one if you'd like. I just, my goodness, I'm sorry. Why is this not working? Okay, I'm really not trying to be bad at this. We're going to add these together, and we get 217 plus what missing measure gives us 360. So we undo that adding and we subtract that 217. And so we would be left with, sorry about that, just the measure of angle x for 143 degrees, which makes sense. If you can see that, it's an obtuse angle, so it's more than 90. Last one, if you feel comfortable, do it on your own. So find the measure of x, this missing value. I can see it's a little bit more than 90 is my prediction. So I have 48 plus 157 plus 55 plus that missing measure is all equal to 360 because it's a quadrilateral, using what I know to find what I don't know, in this case x. Those all add together for 260 plus what number gives me 360, showing my work, of course, even though it might be obvious to myself at this time. Taking away to find out what is left would be an 100-degree angle. You can always plug in your solution to check, which would be a great resource. So, you guys did a great job. Triangles, quadrilaterals, classifying and finding missing angles, using what we do know to solve what we don't know. See you soon.